Okay, in this lesson we're going to look at what's called the present value of an annuity, or the PVA. So we're going to use our good old familiar present value calculation, and we're going to change it up just a bit. So, present value of annuity equals some constant payment, year-over-year payment, or month-over-month payment, times 1 minus 1 over 1 plus k, where k is our rate of return or rate of discount. Talk about that in a second. And n is the number of periods, all over k. So there's our formula. Present value of annuity formula. We're going to keep that off to the side just a bit here. And we're going to now look at an example. So before we do that, I guess we'll talk about it for a second. Present value of annuity equals a constant payment times 1 minus 1 over 1 plus k. K is the discount rate when we're doing a present value, because discounting, we discount back to the present, right? That's the way to think of this. So it's a discount rate, but we can also think of this as a rate of interest. So whatever the rate of interest is our discount rate here, okay? So if you get a rate of interest, Excel is kind of nice because Excel just uses the word rate, and that way we're not confused as to whether it's discount rate or rate of interest. It's just the rate. And then n is their number of periods. And it's important to note that if we're using an annual K, then we need an annual number of periods. If we're using a monthly K, then we need a monthly number of periods. A lot of times, the example I'm going to give you here, we're going to look at an auto loan, and we're going to try to solve for one of these elements. And with an auto loan, a lot of times it's in months, right? It's like a 72-month loan or something like that. And so if this is in months, then this needs to be in months too. We can't use an annual rate and a monthly time period. We have to have them in the same time period. Okay, so let's move that off to the side. And we'll take an example where we're going to buy a truck. And the truck is $35,000. We need 10% down, and our rate of interest is, or our discount rate is 5%. Do we want to use 5%? Yeah, let's use 6%. 6%. That's messy, so let me get rid of that. Okay. 6%. Alright, so what do we want to know here with this question is, what is our payment going to be, right? Payment. So we need to solve for payment. So, put that off to the side. So let's try to solve for payment using our present value of an annuity equation. Okay. So let's say we have the 35,000. We know we need 10% down, so that's 3,500. So we put 10% down, which means we're left with a loan, or a present value is 31,500. Okay, our K is, we know, 6%. And our n, number of time periods, which we didn't actually write down, but we're going to say it's a 72-month loan or a 6-year loan. 72 months. Okay, so that's our information. Now we just have to plug our information into our equation and put that off to the side. Okay. Move everything, give us maximum space here. Alright, so let's go ahead and do that. So we have 31,500 equals payment, which we don't know, times 1 minus 1 over, oh, you know what? Gotta go backwards just a little bit. Sorry. Backwards, backwards, backwards. Sorry to waste your time. Let's go back. Now, one thing that we noticed, and I almost didn't catch myself. See, this is how easy it is to do. We need to make sure we have an annual rate of interest and we have monthly time period. So that's a problem. So we need to change our annual rate of interest into a monthly rate. So what we do to do that is we do what's called an effective annual rate calculation. And the calculation there is to take our 1 plus our rate, our K, divided by the number of months raised to the number of months minus 1. Okay, that's our calculation. So in our situation here, we're going to take 1 plus K, which is 0.06, divided by number of months, which is 12, raise it to the 12th, and then subtract 1. So let's do that calculation real quick. I'm going to do it on my calculator here, so you won't see it, sorry. But we have 0.06 divided by 12 equals, oops, that is not correct. Let me do it on my computer's calculator because it's better than my calculator. 0.06 divided by 12, 0.005. Alright, so we have 0.005, so we have 1.005 raised to the 12th, so we need that. So I'm going to go ahead and find that real quick. Raised to the 12th equals 1.0617 minus 1 gives us 0.0617. So here's our new rate. Okay, that's our new effective annual rate. So if this is our annual rate, this is what we're actually paying. This is our effective annual rate. Why is it more? You should know at this point, reading the chapter, the reason it's more is because we're compounding monthly. Every month the rate is being compounded. Okay, so let's take our 0.0617 as our new rate that we're going to use. And let's put this over here. So we just have to remember that 0.0617. Alright, let's go back into our present value equation. But before we do that, we have to actually remember that we have to make sure these two, the time period and the rate, are lined up. So this is an effective annual rate, which is good. It gives us that 0.0617, which gives us that little bit more of a rate than just the 0.06 would. So we know we're paying a little bit more, okay, because it's going to give us a more accurate calculation here. Now, the more decimal places we run this out to, the more accurate that it'll be, but we're going to stop here at 4 decimal places. But we still have to make it a monthly rate. So 0.0617 divided by 12 is what we're going to have to do. So 0.0617 divided by 12, because remember our n is in months, and that gives us 0.0617 divided by 12 gives us 0.00514. Okay, so here's the rate we're going to use, the 0.00514, which again gives us just a little bit extra here to be able to play with and give us a little bit more of a accurate calculation. So let me go ahead and just push that off to the side. We're going to remember that we're going to use that 0.00514. Alright, so now let's get back into our present value calculation. So 31,500 is our present value of the annuity, equals payment, which we do not know, And now we can start to fill some stuff in. So 1 minus 1 over 1 plus 0.00514 to the 72 all over 0.00514. Alright, now we have some calculations to do. So first thing we're going to do is to go ahead and calculate this. So the first thing we'll do is run this equation down here in the denominator of this ratio in the numerator. And so 1.00514 to the 72nd equals, running on my calculator here, 1.00514 to the 72nd is 1.446. Okay, so now we know that denominator is 1.446, but we know that it's 1 over 1.446. So working our way out of this thing, 1 divided by 1.446 equals 0.69. So 1 over 1.446 equals 0.6915. Okay. Now it's 1 minus what we've just figured out is 0.6915. So 1 minus 0.6915 equals minus 0.6915, 0.3085. Alright, so now we have 0.3085 is the total numerator here. Okay, excellent. So let's go ahead and, oops, got two things going on here. Move that over there. And this one, move over here. All of our scratch pad stuff here. Oops, move that there, move that there. Okay, so what we're left with is 31,500 equals payment times 0.3085 divided by 00514, and we can go ahead and calculate that. 0.3085 divided by 0.00514 equals 60, almost on the button, just 60.02. So 60.02 equals 31.5. So payment equals, multiply both sides by 1 over 60. Multiply both sides by 1 over 60.02. So it zeroes out the right side, leaves us just with payment, and we're going to divide this side by 60.02. And so what we're left with is 31.5 divided by 60.02, and that leaves us with a payment of $524.83. There it is. $524.83 is our payment after all of that. And that's pretty accurate. Now, going back, just so you know, going back, if we didn't do this effective annual rate transformation to figure out what our effective annual rate and stuck with our 6%, this ends up being about 508. So you're quite a ways off if you don't make sure that you do the effective annual rate calculation first. So that's an important piece of this, okay? So just because they give you an annual rate, if you're paying monthly and the contract says that it's compounded monthly, you need to make this effective annual rate transformation. Otherwise, you're going to be misled and you're going to end up thinking you're paying $508 when you make your calculation, when you buy that fancy new truck, when in actuality you're going to be paying $524, which is very different. Okay, very good. So, that is a use or a application of the present value of an annuity equation. I hope everything was pretty clear. I know that, when you stop and look at this screen, it looks like a bunch of mush, but hopefully you followed my application of that to get to our payment of $524.83. Okay, see you in the next lecture.